Today we're working on lesson 2.2 and 2.3. I combined these two lessons because in the book they were separate, but they're basically the same thing. So instead of doing 2 separate days of notes, I combined it into one day. So 2.2 is focused on addition, 2.3 is focused on subtraction of rational numbers. If you think back to the definition that we had of rational numbers, we know that rational numbers are decimals and fractions. For today's lesson, we're going to be working primarily with fractions. Before we get started, we have to talk about the rules for adding or subtracting. The first thing that we're going to do is we're going to make both of our numbers improper fractions. The second thing we're going to do is get a common denominator. And the third thing we're going to do is add or subtract the numerators and keep the denominator. So let's go over what these mean. We're going to start off by talking about making both numbers improper fractions. So in front of you, you see 3 1/4. This is written as a proper fraction. We need to change this proper fraction to be an improper fraction. I know that this is currently proper because we have a whole number out front and our numerator is less than our denominator. If it was an improper fraction, the numerator would be more than our denominator. So in order to convert this proper fraction to be improper, we're going to take our denominator and multiply it by our numerator. When I take 4 times 3, I get 12. Next, we have to add in the numerator. So we're taking 4 times 3, which equals 12, plus 1, which equals 13. And now I have my new numerator. So I'm going to take that 13 and put it on top. And I'm going to take my old denominator and put it on bottom. So I know 3 1/4 is equal to 13 over 4. Those are two equivalent numbers. The next thing we have to talk about is finding a common denominator. So when you're adding or subtracting fractions, they must have a common denominator. So I've got 1/2 plus 1/3 as our problem we're looking at. The first thing that I notice about these two numbers is the denominators are not common numbers. In order to make a common denominator, we have to think about our least common multiple. So this is the table that I used in yesterday's lesson. This one is kind of easy because both of these numbers are prime numbers, which means that they're only divisible by 1 in themselves. So I know the only number that they're both divisible by is 1. 2 divided by 1 gives me a 2. 3 divided by 1 gives me a 3. And I am looking at my L. If you remember from yesterday's lesson, for least common multiple, we're looking for our L. And so we're looking at all the numbers in that L shape. And then we're going to be multiplying those numbers. So I'm taking 1 times 2, which equals 2, and then times 3, which is going to be equal to 6. So I know the least common multiple between 2 and 3 is 6. When we're adding or subtracting fractions, they must have that common denominator. We just found that the least common multiple of 2 and 3 is 6. So when I'm rewriting these fractions, I know that I'm going to have to write 6 in my denominator. The next thing I need to figure out is what my numerators are. So in math, we can't just magically change things. There's some mathematical reasoning behind everything that we do. And so you know that you're going to have to multiply these two numbers. We're asking ourselves 2 times what is going to give us 6? And the answer is 3. 2 times 3 gives us 6. Whatever I do to the bottom of the fraction, I have to do to the top of the fraction. So since I multiplied the denominator by 3, I have to multiply the numerator by 3. 1 times 3 gives me a 3. We're going to do the same thing to fraction 2. We're asking ourselves 3 times what gives us 6? And the answer is 3 times 2 gives us a 6. Whatever we do to the bottom, we have to do to the top. So I've got 1 times 2, which gives me a 2. Now, since these two fractions are equivalent to the fractions that we had before, and they have a common denominator, I can add them together. So let's put everything that we've learned together. The first thing that we have to think about is making our proper fractions improper. So if I'm looking at these two numbers here, I can see that the second number is written as a proper fraction, but that numerator is not larger than the denominator. So this fraction is fine. This one is a proper fraction as well, but I have a whole number out front, which I don't want. I want that denominator to be bigger than my numerator. So in order to change that, I have to do 5 times 1, which is 5, plus 2, which is 7. Now I need to find a common denominator. I see my denominators are currently 5 and 10. So I'm going to use my chart, just like I did before, and I'm thinking about what goes into 5 and 10. And my answer is 5. Both those numbers are divisible by 5. 5 divided by 5 gives me a 1. 10 divided by 5 gives me a 2. We're looking for our least common multiple, so I am looking at this L shape here. And I'm just going to multiply those three numbers. 5 times 1 gives me a 5, and 5 times 2 gives me a 10. So I know the least common multiple of 5 and 10 is 10. This was our original problem. I know that I have the common denominator of 10, and I got those new numerators by multiplying my denominator. So for that first fraction, 5 times what gives me a 10? 5 times 2 gives me a 10. Whatever I do to the bottom, I have to do to the top. So I've got 7 times 2 is equal to 14. This second fraction, the denominator is already a 10. So all I did was rewrite it over there. Technically, I multiplied by 1, which kept it the same. When you are adding or subtracting fractions, you're just going to add or subtract the parts or the numerators, not the wholes, which are the denominators. This is an addition problem, so I'm taking 14 plus 1, and that's going to give me 15. And then we keep our denominator. So my final answer to this problem here is 15 over 10. I can also simplify that fraction if I choose to. I'm not going to always require you to do this, but it's good practice. 15 and 10 are both divisible by 5. 5 is actually the greatest common factor of those two numbers. So I'm going to divide both of those numbers by 5, and I get 3 over 2. Let's practice some more. I want you to pause the video and try this problem out, and then I'm going to show you my work over on the right-hand side when you are done. And here's my answer. So the first thing that I did was I took 5 times 1 plus 1 and got 6. And so that was going to be my new numerator, and I kept my denominator. I noticed that both of these denominators are already common, so all I had left to do was to subtract my two numerators. 6 minus 3 gives me a 3, and then I keep my denominator. So my final answer is 3 over 5. Now let's try this one. Notice that this first rational number is negative. So you're taking a negative 9/14 minus 2/7. Since this is a subtraction problem, make sure that you KCO for this one. Try this problem on your own. I'm going to pause the video and you should too, and I'm going to give you the answer when you are done. And my final answer is negative 13 over 14. I got that number because first thing I checked was I made sure that both numbers were written correctly, and they were in this case. So the second thing I did was I noticed that the denominators were not common. I know that the LCM, or least common multiple, of 14 and 7 is 14. I don't have to change anything on this first fraction because the denominator is already a 14. However, I do have to change my second fraction. In order to do that, I take 7 times 2 to get 14, and 2 times 2 to get 4. One thing to note before I move on is a fraction written like this, so negative 9 over 14, is the same as negative 9 over 14, which is the same as 9 over negative 14. Remember that a fraction is a division problem. So if I have one positive number and one negative number, and I'm dividing them, my answer is going to be negative. So I can put that negative sign out front with the numerator or with the denominator. It all means the same thing. So when I was writing my fractions, I put the negative with my 9. I put it with my numerator because that denominator just stays the same throughout the whole thing. I'm messing with my numerator. I'm going to be subtracting my numerator. And so I needed that negative to be grouped up with that 9. Like I told you to do, you're going to KCO it, so it was a subtraction problem. So it was written like that. Negative 9 minus 4. What I did was I made that addition, so keep, change, opposite. Now I have negative 9 plus negative 4, and I get negative 13. Keep my denominator, which is 14, and I get negative 13 over 14. The next thing that I have to talk about is ordering integers. So I want to order all of these integers from least to greatest. I have some fractions and some decimals. So the first thing that I'm going to do is I'm going to make sure that they're all written in the same language. By language, I mean they're all written as decimals or they're all written as fractions. My personal opinion is that decimals is the easier thing to change everything to. And that's because if you're working with fractions, they have to have the same denominator. And so if they don't have the same denominator, it's going to cause a lot of pain and frustration for you. So let's look at these two fractions that I have and convert them to decimals first. Negative 1/3 is equivalent to negative 0.3 repeating. Negative 5 over 3 is equivalent to negative 1.6 repeating. I found those two numbers just by using my calculator. I divided the numerator by the denominator. So 1 divided by 3 and 5 divided by 3. Now that I have these original numbers written in decimal form, I can work on ordering them. To order these efficiently, what I'm going to do is look for my negative signs. So I'm looking for all of my negative numbers, and I have 3 of them. I know that those negative numbers are going to come first because negative numbers are always smaller than positive numbers. And so I'm looking at -5 or negative 0.5, negative 0.3 repeating, and negative 1.6 repeating. When we're thinking about negative numbers, the more negative it is, the worse it is. Think about money. And when we're in negatives, think about owing money. Would you rather owe somebody 50 cents, 33 cents, or $1.66? Out of those 3 options, I'd rather owe somebody 33 cents because it's not as much. That means that negative 0.3 repeating is going to be our greatest number. And so these other 2 numbers are going to come before. If I'm looking at those 2 numbers only, I'd rather owe somebody 50 cents than $1.66. So I know that that one's going to come next. And that makes my least number that negative 1.6 repeating. Now that I have my negative numbers out of the way, I'm going to work with those positive numbers. Positive numbers, I'm looking at 50 cents and $1.25. I would rather have $1.25 over 50 cents, so I know 1.25 is going to be the bigger number, which leaves our last spot for that 0.5 number. Now that I have these numbers in order, I have to make sure that I go back and I use the original numbers. So when I wrote that negative 0.3 repeating, I should be writing negative 1 over 3. And then for my negative 1.6 repeating, I should be writing negative 5 over 3. Now that I'm back to using my original numbers, I can quickly double check myself because all my negative numbers are on the left, all my positive numbers are on the right, and that's going to be my final answer. Well, I gave you the answers, so let's go in and ignore that part. Try to order these numbers from least to greatest. You obviously saw the answers already, so just ignore that portion of it and try to solve it on your own. And there's your final answers. So you're ordering them from least to greatest, so we only have 2 negative numbers, and they actually came to you in order. That is followed by 1/4, and then 0.9, and then 9 over 2. If you don't understand this, please send me an email and I will explain it further. This is your homework, so it's only going to be 8 problems. Remember at the beginning of the lesson when I told you that I'm taking from 2 different sections? That's why it's on 2 different page numbers. So these 4 problems are from 2.2 and these 4 problems are from 2.3.